reading. Max. Hello. Okay, start reading, Tanav. Fun with magnets.
Yes, mom. Paheli and Buju went to a place where a lot of waste material was piled into huge heaps. Something exciting was happening. A crane was moving towards the heap of a junk. The long hand of the crane lowered a block over a heap. It then began to move.
Okay.
Guess what? Many pieces of iron junk were sticking to the block as it moved away. See in Pig Point 13.1.
Okay. Skip this part. Now read how magnets were discovered.
Okay, ma'am. It is said that there was a shepherd named Magnus who lived in ancient Greece.
Beta, underline this
He used.
line. It was
Yes, ma'am.
discovered by Shepherd Magnus. Underline this
Yes,
line. It was discovered by Shepherd Magnus, who lived in ancient Greece.
ma'am, I have underlined this one.
Okay.
He used to take his herd of sheep and goats to the nearby mountains for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached at one end. One day he was surprised to find that he had to pull hard to free his stick from a rock on the mountainside. Step 13.3. It seemed as if the stick was
बेसिकली
by the rock.
मैग्नस ने ये देखा कि उसकी रोड मैग्नेट बन गई है. In any case, people now
Yes,
have discovered that certain rocks have the property of attracting pieces of iron. They also found that small pieces of these rocks have some special properties. They named these naturally occurring material magnets. तो बाद में फिर मैग्नेट बनाना भी शुरू कर दिया लोगों ने. Activity 1 Grisha, you read बेटा.
Yes, ma'am. Take a plastic or paper cup. Fix it on a stand with the help of a clamp as shown in figure 13.5. Place the magnet inside the cup and cover it with a paper so that the magnet is not visible. Attach a thread to a clip made of iron. Fix the other end of the thread at the base of the stand. Mind you, the trick involved here is to keep the length of the thread sufficiently short. Bring the clip near the base of the cup. The clip is raised in air without support like a kite. (10.1) Magnetic and non-magnetic material. Activity 2. Only this time we will change the position of the magnet and the iron. There will be a magnet at the end of our shepherd's stick. We can attach a small magnet to a hockey stick, walking stick, or a cricket wicket with a tape or some glue. Let us now go out on a Magnus walk through the school playground. What does our Magnus stick pick up from the school ground?
Okay.
What
wait.
about objects?
Next, we understand that we understand that magnet attracts certain materials where some do not get attracted towards magnets. These materials which get attracted are magnetic, and which are not attracted are
non-magnetic.
okay. Bojo has this question.
Mom, today at last we will. Mom, today at last we will study current affairs, na?
Yes. Bojo has this question for you. A tailor was stitching buttons on his shirt. The needle has slipped from his hand onto the floor. Can you help the tailor to find the needle? We'll use magnet, isn't it?
Yes, ma'am.
ठीक है. Activity 3. Armia, you read.
Okay, ma'am. Rub a magnet in sand or soil. Put the magnet
Are there some particles of sand or soil sticking to the magnet? Now gently shake the
Okay,
magnet to
this
remove
Arnya,
the
this
particles.
activity is like we rub the magnet into the sand or soil. When we rub, some particles will stick, as is shown in the figure ABC. As is shown in the figure, some particles will stick to the magnet. So it is telling that in sand also there are certain pieces of iron. Okay, it is simple. Now you can read activity poles of the magnet पे जो activity है ना वो read करो आन्या. Activity 4.
Before,
Hmm.
okay. Set some iron fillings on a sheet of paper. Now place a bar on magnet sheet. What do you observe? Do the iron fillings stick all over the magnet? Do you observe that more iron fillings get attracted to some parts of the magnet than others? Figure 10.7. Remove the iron filling sticking to the magnet and repeat the activity. Do you observe any change in the pattern with which the iron fillings get attracted by different parts of the magnet? You can do this activity using pins or iron nails in place of iron fillings and also with magnets of different shapes. Draw a diagram to show the way iron fillings stick to the magnet.
Okay, there is a
Is your
line
drawing
that
clear?
there is a line in the below that we find that iron fillings are attracted more towards the region close to two ends of the bar magnet. So these are known as poles. Please underline this line that these are known as pole magnet. What do we say to them? They are always in the ends. Try and bring few magnets of different shapes to the classroom. Check for the location of poles. Can you now mark the location of poles in the kind of magnets? 13.4. 13.4, where is it? Yes, magnets of different shapes. It is asking for this. Let's study directions. Do you know there was a king? His was died. उन्होंने एक डोल को लगाया हुआ था अपने चैरियट पे. कैन यू सी द पिक्चर ऑन द पेज नंबर 129? देयर इज अ पिक्चर
Yes,
हियर
ma'am.
ऑन दिस चैरियट. उन्होंने ऐसी एक डॉल को या ऐसी फिगरिन को लगाया हुआ था. उसके ऊपर एक हैंड था. सो इट वाज बेसिकली ए मैग्नेट. इट वाज ऑलवेज अलाइनिंग टुवर्ड्स साउथ डायरेक्शन. So it was always directed towards south direction. तो ये जो प्रॉपर्टी था, इस प्रॉपर्टी से उसको अपना रास्ता मिल जाता था. So now we will find directions with help of a magnet. We'll do activity number 5.
Ma'am, okay, ma'am. Activity 5. Take a bar magnet, put a mark on one of its ends for identification. Now tie a thread at the middle of the magnet so that you may suspend it from a wooden stand. Figure 13.9. Make sure that the magnet can rotate freely. Let it come to rest. Mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest.
Draw
a line joining the 2 points. Line shows the direction in which the point is position of rest. Let the magnet by in any direction and let it come to rest. Again, mark the position of 2 ends in its position of rest. Does the magnet now point in a different direction? Rotate the magnet in other directions and note the final direction in which it comes to rest. Do you find that the magnet always comes to rest in the same direction? Now, can you guess the mystery behind the statue in the Empire's chariot? Repeat this activity with an iron bar and the plastic or a wooden scale.
It is telling that magnet always comes in one direction. You should use a light magnet without air currents. We find that freely suspended bar magnet always come to rest in particular direction, which is, please underline this line. We find that freely suspended bar Underline this line, Shaurya. This one. We find that freely suspended bar of magnet freely suspended, it always comes in north-south direction. Use the direction of the rising sun in the morning to find out the rough direction towards east where you are doing this experiment. If you stand facing east, to your left will be north. Using the sun for finding direction may not be very exact, but it will help to make out the direction north from south. So in this page it is given that the property of magnet is very useful to us. ये जो आपको दिख रहा है कंपस, इसके अंदर इसी प्रॉपर्टी को यूज़ किया जाता है. लास्ट स्टेंजा में दिया हुआ है लेटर ऑन अ डिवाइस वाज डेवलप्ड ऑन दिस प्रॉपर्टी ऑफ मैग्नेट्स. इट इज़ नोन एज कंपस. प्लीज अंडरलाइन कंपस. Compass is a very small box with a glass cover. A magnetized needle is pivoted inside the box, which can rotate freely. The compass also has a dial in which directions are marked at the place where we wish to know the directions. Its needle, because it's a freely suspended magnet, we have read that freely suspended magnets always align towards north-south direction. The compass is then rotated until the north and south marked on a dial are at the two ends of the needle. To identify the north pole of the magnetic needle, it is usually painted in a different color. ठीक है, समझ आया ये डायरेक्शंस वाला. Now there is an interesting fact that we can make a magnet. It's very interesting. Okay.
Yes, ma'am.
Just read it. Who wants to read? किसकी बारी है?
Ma'am, Pranavi.
Yes, Pranavi.
Ma'am, can I, Grisha?
Yes, उसके बाद Pranavi, then Grisha.
Okay, there are several methods of making magnets. Let us learn the simplest one. Take a rectangular piece of iron. Place it on the table. Now, take a bar magnet and place it on.
इसमें ये दिया हुआ है ग्रिशा कि जब एक हम पीस ऑफ आयरन को बार बार किसी मैग्नेट पे वो करते हैं, स्क्रैच करते हैं, बार बार मूव करते हैं, तो वो मैग्नेट बन जाता है. सेवरल मेथड्स हैं. इसके अंदर दिया हुआ है कि टेक अ बार मैग्नेट, प्लेस वन ऑफ इट्स पोल नियर वन एज विदाउट लिफ्टिंग द मैग्नेट, मूव इट along the length of the iron bar till you reach the other hand. Now lift the magnet and bring the same pole you started with to the same point of iron bar from where you begin. मतलब north to south उस पर मूव करते रहना है. ये डायग्राम देख रहे हो? ये डायग्राम देखो. मूव द मैग्नेट अगेन अलोंग द आयरन बार इन द सेम डायरेक्शन एज यू डिड बिफोर. रिपीट दिस प्रोसेस 30-40 times. Bring a pin or some iron fillings near the iron bar to check whether it has become magnet. अगर वो नहीं बना है then continue to do so. Activity 6 पढ़ो ग्रिशा.
Using a bar magnet. Now, insert the magnetized needle through a small piece of cord. The cord float in water in a bowl or a tub. Make sure that the needle does not touch the water. Your compass is now ready to work. Make a note of the direction in which the needle points when the cork is floating. Rotate the cork with the needle fixed in it. In different directions, note the direction in which the needle points when the cork begins to float again without rotating. Does the needle always point in the same direction when the cork stops rotating?
What do you think?
Yes, ma'am.
Yes, it will be, because it is a magnet and it always aligns in motion. Attraction and repulsion between magnets. ये आपने देखा भी होगा. Let us play another interesting game with magnets. Take two small toy cars and label them A and B. Place a bar magnet on top of each car along its length and fix them with rubber band. Okay. Pranavi, आप पढ़ो.
रबर. Ma'am, I am Pranavi.
Pranavi, आप पढ़ो बेटा.
Yes, ma'am. In car A, keep the south pole of the magnet towards its front. Place the magnet in opposite direction in car B. Now place the two cars close to one another. Figure 13.13.
Okay. This
What
is
do you
a
observe?
simple experiment in which similar poles they repulse each other and opposite poles attract each other. जब diagram दिया हुआ है ना, When north and
Yes,
south
ma'am.
है इकट्ठे तो they repulse.
Yes, ma'am.
Hmm.
Do the cars remain at their places?
This is just an iron, na? This is very
Do
thin
the
iron
cars
actually.
run away from each other? Do they move towards each other and collide?
It has to be bar
Record your
magnets.
observation in the table as
इसमें
shown in
ज़्यादा
table
इसमें बंद हो रहा है ना
13.3.
north south ये
Now,
पतला है
place the toy car
क्योंकि
close to
इसमें
each
डिफरेंस
other
होता है ऐसे
such
ऐसे होता
that
है
the
ऐसे ये
rear
गैप होता
side
है
of the car
इसमें
A
मर्ज हो रहा है
faces the front side of car B.
और वैसे
Figure
भी this is not a magnet
13.14.
this is not a
Do
magnet
they move as before? Note the directions in which the car move now. Next, place the car A behind the car B and note the directions in which they move in each case. Repeat the activity by placing cars with their rear sides facing each other. Record your observation in each case. What do you find from this activity? Do two similar poles attract or repel each other? What about opposite poles? Do they attract or repel each other? This property of the magnet can also be observed by suspending a magnet and bringing one by one the poles of other magnet near it.
ठीक है few questions everybody please write down few questions
Ma'am, can I read next?
yes Ira magnets few questions लिखो पहले magnet lose their properties number 1 by heating by hammering dropping from some height
Ira, repeat it once again.
it's there in your book magnet lose their properties if they are heated hammered or dropped from some height Ira read next
Okay, ma'am. Ma'am, I don't have my book.
I'm sharing it beta
Okay, ma'am.
Ira you don't join class on time
Ma'am, I joined the class on 8:25.
no you should join in time beta
Okay, ma'am.
it's a short class also magnets become weak if they are not stored properly
Ma'am, I'm Pranasha and Pranavi. Ma'am, we are very, very sorry because we joined late for the class.
कोई नहीं आप keep safe keep them safe
We were eating food and we didn't saw the time.
okay to keep them safe bar magnets should be kept in pairs with their unlike poles on the same side they must be separated by a piece of wood you can see in the picture also na padho
They can be separated by a piece of wood while two pieces of soft iron should be placed across their ends. Figure 13.16. For horseshoe magnet, one should keep a piece of iron across the poles. Keep magnets away from cassettes, mobiles, television, music system, compact disc, CDs and computer.
summary padho magnetite is a magnetite
Magnetite is a natural magnet. Magnet attracts materials like iron, needle.
Okay, Ira, read this paragraph. We skipped this paragraph actually. ये वाला. It's this one. It seemed as if the stick was being
attracted by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd's stick. It is said that this is how natural magnets were discovered. Such rocks were given the name magnetite, perhaps after the name of that shepherd.
Yes.
Magnetite contains iron. Some people believe that magnetite was first discovered at a place called Magnesia. The substances having the property of attracting iron are known as magnets. This is how the story goes. In any case, people now have discovered that certain rocks have attractive pieces of iron. They also they also found that small pieces of these rocks have some special properties. They named these naturally occurring materials magnets.
Yes.
Later on, the process of making magnets from pieces of iron was discovered. These are known as artificial magnets.
Yes.
Nowadays, artificial magnets
Are prepared in different shapes. For example, bar magnet, horseshoe magnet, cylindrical or ball-ended magnet.
we are reading the chapter again.
No, I skipped that part. So I saw in summary, na, we didn't study about magnetite. So I wanted to study it. Beta. Today I skipped certain lines, na, so that I could teach Lakmeer Singh also. इसीलिए I hurried it up. Okay, now I have pointed some certain points from Lakmeer Singh. Yes, Peter.
Ma'am, I have a fact. Ma'am, a piece of a magnetite rock is also known as a lodestone.
Piece of?
Ma'am, a piece of a rock magnetite is called as lodestone.
Okay.
And ma'am, reading stone too.
Okay. Now
Yes, ma'am.
there is a very good concept in Lakmeer Singh. Let's study this. Earth as a magnet. Earth as a magnet. Okay, Tanav, you read it.
Ma'am, screen is okay. Sir William Gilbert, an English scientist and physician, was the first person to suggest that the Earth behaved as a giant bar magnet. This was based on the observation that a freely suspended bar magnet always comes to rest in the north-south direction. The Earth's magnetic south is at the geographical north and the magnetic
North is at the geographical south, because we see na opposite poles attract. So whenever we keep magnet in a free direction, we keep magnet as free, then it always align in north-south direction. So they are telling that Earth is a giant magnet. क्या हुआ? मुझे मिराय को देखना. Earth is a giant magnet where its geographical north is magnetic south and geographical south is magnetic north. Can you see this diagram?
Yes, ma'am.
Can you see this diagram?
And ma'am, the Earth's core is mainly made up of iron, and ma'am, it is the one of the best material for making magnets.
Yes. Good. So, okay. Attraction and repulsion हो गया. Now,
Iron is also the strongest conductor of magnet.
who is this? किसने join किया? सर्वज्ञ? Anybody जिसने अभी read नहीं किया है, tell me your name. This magnet.
हम सर्वज्ञ की बारी नहीं है.
Sarvagya, do you want to read? Uses of magnets. Please everyone write this. Magnets are used to hold objects. Number 1. Magnets are used to separate discarded iron and steel objects from the waste. Third, magnets are used for making compasses. Fourth, magnets are used in telephones, hair dryers, doorbells, mixer grinders, fans, washing machines, television sets, tape recorders, electric motors, electric generators, and various types of toys. We will now describe some of the uses of magnets in details. Please, anybody read it?
Ma'am, can I read? Ma'am, can I read Pranavi?
Pranavi, you
Ma'am,
read
can
it.
I read Grisha? Okay, ma'am. Uses of magnets. Magnets are used for a large
Read
number of
read
purposes.
the last paragraph.
Some of the important.
Read the
Okay,
last
ma'am.
paragraph. We have all seen
We will
stickers.
now describe some the. Okay, ma'am. Oh, we have all seen stickers that can be attached to iron and steel objects such as refrigerator, okay, ma'am, and almirahs, doors. Such stickers have flat magnet or button magnets below them. See figure 18a. These magnets sticks to the steel doors of a refrigerator or almirah and hold the sticker. Thus, magnets are used in stickers to hold them on a steel door or a refrigerator and almirah. We all know that the doors of a refrigerator, ma'am, what is written?
क्या बेटा? We all know that the door of the
Ma'am,
refrigerator
refrigerator.
remains tightly closed. This is also due to use of magnets. If you open the door of a refrigerator and look it carefully, we will see a lining or rubber all around. Inside this rubber lining is a long and thin strip of magnet. Okay. Now we'll write about properties of magnet. Number one property of magnet is properties of magnets. Number one property of magnet is a freely suspended magnet is always points
always
in
in direction,
north
north and
south direction. ठीक है? Always point in north south direction. The
Yes, ma'am.
the end of the magnet which points towards the north
Ma'am,
direction
yes,
is called
we'll have the stand.
huh?
Ma'am, we'll have ma'am, poles.
End of the magnet which points towards the north direction is called north seeking end or north pole of the magnet. In figure 7, there is a figure here. In figure 7, north pole of the magnet has been marked north and the end of the magnet which points south direction, south seeking end is marked S. We usually call them north and south poles. Okay. तो आई थिंक मैग्नेट आसान है, समझ आ गया होगा सबको.
Yes, ma'am.
Okay, second property of the magnet. Please write down the property. Number one property, a freely suspended magnet always points in north-south direction. A freely suspended magnet always points in north-south direction. Second property is like magnets repel. Second property is like magnetic poles repel.
And ma'am, unlike magnets, do not ma'am attract.
Okay, like magnets.
Ma'am, like magnets are like north and south and south.
Yes.
Excuse me, ma'am. Someone else's mic is on.
Okay. Okay. Now, can anybody share with me the current affairs second page? We did first page that day.
Yes, ma'am. Ma'am, I have written them in my register.
No,
Ma'am,
not
what
written.
I have shared the whole PDF of the current affairs.
Okay, I will check it. Beta.